We have already discussed that bosses are usually rather dumb. We've also discussed why they tend to be so dumb. Specifically, they don't listen a lot, they don't know a lot, and they think they know a lot. This is a pretty toxic cocktail of qualities, and that's why bosses are so fond of saying, just give me the 10-second version. And when bosses say that, what you should do is just give them the average. Every now and then, we get a rare specimen of a boss who's a little less dumb. This boss says, give me the 30-second version. Clearly, a 300% increase in the attention span of your boss merits a substantial increase in the amount of information that you give him. For such a boss, give him not just the mean, but also the standard deviation. Jokes apart, again, this point is an important one. If you need to summarize data using just one number, use the mean or the average. If you need to summarize data using two numbers, use the mean and the standard deviation or some other similar measure of dispersion. This section talks about measures of dispersion or of spread. Let's understand what these are and why they are useful. The mean, the mode, and the median are all measures of the central point in a dataset. In other words, if you had to pick just one value to represent an entire dataset, you'd pick one of these. In that sense, the mean, the median, and the mode are all vertical measures. They help you measure a representative vertical value. In contrast, the interquartile range or standard deviation both help describe the spread of a dataset. These are representatives of the horizontal extent of the dataset, how variable the dataset is across different values within the dataset. Let's try and make this real with an example. Let's say that you are a toy manufacturer and you make toys of a certain fixed size. The size of the toys that you make is 10 centimeters. Now, what you'd like to do is to outsource the packaging for your toys. You want to stick to your core competencies, to use one of the favorite terms of bosses. Now, because you know that you precisely manufacture your toys to be exactly 10 centimeters tall, you would like the packaging to reflect this. You call in for bids and you ask two manufacturers to send in a bunch of samples, and you stipulate that you would like the samples to also be exactly 10 centimeters high. The two contenders send their bids in terms of their samples, and what you find is that the samples which these two folks send you look pretty different. Contender 1 sends you a bunch of different packaging. The average height of this packaging varies substantially from 7.8 centimeters for the smallest to 14.2 centimeters for the tallest. The mean, however, of all of these packages is 11 centimeters, in other words, pretty close to what you had asked for. Contender 2 sends in also a bunch of samples. These samples also have a mean height of exactly 11 centimeters. So when you look at only the means of these two contenders, you really can't tell them apart. Intuitively though, there's something wrong with what contender 1 has sent in. There just seems to be too much variability in the packages that he has sent in. By that measure, contender 2 is better, and that's because the spread in the sizes of the containers is smaller for contender 2 than for contender 1. This is exactly the concept that is captured in the interquartile range and in standard deviation. Let's now go through and understand exactly what these formulae mean and how they translate into a measure of the spread or the dispersion in a set of data. Let's say that we were to create histograms of the heights of the packages sent in by these two contenders. We'd get a pair of bar charts, contender 1 and contender 2. You can see now the histogram for contender 1 and now that for contender 2. Remember that a histogram is simply a bar chart of the frequency table representing a bunch of data. As you can tell, with both of these graphs, they are clustered around the same central point, which is the interval of 11 to 12. So as measured by their central point, possible to tell these two contenders apart. But even so, the shape of the histogram indicates to us that there is something wrong with contender 1. And why is that? It's because Contender 1's data has way more variation horizontally. The difference between the smallest and the largest values for contender 1 is a lot greater than it is for contender 2. Among sportsmen, these graphs would correspond to a very inconsistent versus a very regular and consistent sportsman's performance. In real life and in statistics, you only really have the measure of a set of data when you know not just the average value or the average performance, but when you also know how variable that performance or that value is. Now, just as there are multiple ways to find the central point, such as the mean, the median, and the mode, similarly, there are multiple ways to find the spread. The commonest of these are the interquartile range and standard deviation. So let's make sure that we understand each one of these. Let's first talk about how the interquartile range is captured. To measure the interquartile range, sort your data in ascending order. Next, divide your sorted data into 4 groups of equal size. Again, sort your data and then divide the sorted data into 4 equal parts. Let's call these Q1, Q2, Q3, and Q4. Now the points in your data which mark the partitions of these 4 equal parts are called the quartiles. Once again, divide your sorted data into 4 equal parts, and the partitions or the boundary values between these 4 equal parts are called the quartiles. How many of them will you have? Well, you'll have 4 intervals and 3 defining values. Call these defining values Q1, Q2, and Q3. The first and the last quartile are bounded on their outer edges by the smallest and the largest values. We are not considering those here in our conversation. Now, if you think about it, the second quartile is nothing but the median. Remember that the median is simply the value such that half of the data is on one side of the value of the median and the other half is on the other side of the median. The first quartile, similarly, can be simply thought of as the median of the first half of the data, and the third quartile can be thought of as the median of the upper half or the second half of the data. The distance between these two quartile points, Q3 and Q1, is called the interquartile range. Q3 minus Q1, which gives us a good amount of information about the amount of dispersion in the data, is termed the interquartile range or the IQR. When we plug in the formula, we find that the value of Q3 is 11.3, the value of Q1 is 10.2, and the interquartile range is 1.1.